LangGraph employs a question rewriting mechanism to enhance semantic clarity when retrieved documents fail relevance checks. This functional component operates as a self-contained transformation node within the state management system, accepting a MessagesState input and returning a modified message payload. We're about to examine how the system initializes this rewriting pipeline by formatting the original query into a structured prompt template, then invokes the language model to generate an improved question variant while maintaining state consistency through message passing. From LangChain, messages import human message. Rewrite prompt equals. Look at the input and try to reason about the underlying semantic intent / meaning, \n. Here is the initial question. \n. Question. \n. Formulate an improved question. Def rewrite question state. MessagesState. Rewrite the original user question. Messages equals state messages. Question equals messages 0. Content. Prompt equals rewrite prompt. Format question equals question. Response equals response model. Invoke role. User content prompt. Return messages. Human message content equals response content. This code implements a question rewriting component for a retrieval augmented generation system. The rewrite question function takes the current conversation state, extracts the original user question, and uses a language model to generate an improved version of that question when retrieved documents aren't relevant to the original query. The approach follows a prompt engineering pattern where the system analyzes the semantic intent behind the user's question and reformulates it more effectively. This is particularly valuable in RAG systems where initial retrieval attempts might fail due to poorly phrased queries. The function maintains the conversation state by returning a new MessagesState with the rewritten question as a human message, allowing the system to attempt retrieval again with the improved query. The trade-off here is between computational cost, additional LLM call, and retrieval effectiveness. This pattern assumes that question reformulation will lead to better document retrieval in subsequent attempts, which is often true for complex or ambiguous queries. The implementation keeps the state management simple by only preserving the rewritten question, discarding previous message history to start fresh with the improved query. Let's break it down. From LangChain, messages import human message. Imports the human message class from LangChain's messages module, providing a message type specifically for representing human user input in conversational chains. Rewrite prompt equals. Defines a constant variable, rewrite prompt, and assigns it an empty tuple. This creates a placeholder for what appears to be a prompt configuration, though the actual prompt content isn't visible in this segment. The empty tuple suggests this might be initialized elsewhere or used as a default value. Look at the input and try to reason about the underlying semantic intent / meaning, \n. Prompts the system to analyze the input and infer the underlying semantic intent or meaning, focusing on understanding what the user is trying to achieve rather than just processing the literal text. This suggests an AI-driven reasoning step to extract higher-level context or purpose from the input. Formulate an improved question. Prompts the system to generate a refined version of the input question, likely to improve clarity, specificity, or structure for better processing or understanding. This appears to be part of a question answering or query refinement pipeline, where the original question is being enhanced before further handling. Def rewrite question state, MessagesState. Rewrite the original user question. Defines a function named rewrite question that takes a single parameter state of type MessagesState. The docstring indicates this function's purpose is to rewrite the original user question, though the implementation details aren't visible in this segment. The function signature suggests it operates on some message state object, likely containing conversation context or the original question to be transformed. Messages equals state messages. Extracts the value associated with the key messages from the state dictionary and assigns it to the variable messages. This retrieves the message history or conversation context stored in the current state for further processing. Question equals messages 0, content. Extracts the content from the first message in the messages collection and assigns it to the variable question. This assumes messages is an ordered sequence where the first element has a content property containing the question text. Prompt equals rewrite prompt. Format question equals question. Formats the rewrite prompt template string by inserting the question variable into its placeholder, creating a complete prompt string ready for use. The resulting prompt variable contains the fully interpolated text with the question embedded in the predefined template structure. Response equals response model, invoke role. User, content, prompt. Invokes the response model with a single user message containing the prompt text. The invoke method is called with a list containing a dictionary that specifies the role as user and the content as the value of the prompt variable. This triggers the model to process the user's input and generate a response. Return messages. Human message content equals response, content. Returns a dictionary with a messages key containing a list with a single human message object, where the message content is taken from the response's content attribute. This question rewriting component demonstrates LangGraph's stateful transformation pattern, where a self-contained function operates on the conversation state to improve query effectiveness. The workflow begins with extracting the original question from the message state, then uses a carefully designed prompt template to guide the language model in semantic analysis and reformulation. By returning a new state containing only the rewritten question as a human message, the system effectively resets the conversation context while maintaining the state management structure. The key insight here is the deliberate trade-off between computational cost and retrieval quality. Each rewrite operation incurs an additional LLM call, but this investment aims to improve document relevance in subsequent retrieval attempts. The implementation keeps the state transition clean by discarding previous message history, ensuring the rewritten question becomes the new starting point for the next retrieval cycle. This pattern particularly shines when dealing with ambiguous or poorly phrased queries, where initial retrieval attempts fail to surface relevant documents.
The retriever digs for documents, while the question rewrites itself. Yet the answer waits for context to whisper its secrets.